In this video, we're going to look at using triangles and circles to find area. And you might be wondering, well, why? Well, because maybe that's a better shape or an exact shape to use rather than rectangles. So let's take, for instance, this integral from -1 to 2 of 2x minus 2 dx. So let's first graph and shade which region we're talking about, okay? So this region would be, let's see, 2x minus 2 would have a y-intercept of -2. I'm going to have a slope of 2 over 1. Okay. And then go down and down. Okay, I think that looks good. Almost looks good. Okay. Perfect. Now, of course, this line keeps going. And let's label some stuff. This is -4, this is -1, this is 2, this is 2. I think that looks pretty good. And this is 1. Okay, this area that I'm finding is this area and this area. Can you see how finding the area of two triangles would probably be more useful than doing a left, right, or midpoint Riemann sum? I sure hope so. Okay, so what we're going to do is we're going to find the area of each triangle, and of course the area of a triangle is 1/2 base times height. But what we're also going to do is make sure that we account for whether it's positive area or negative. So this is positive. This, however, is a negative. So when I take and add them together, my net will be negative since this one's bigger. Okay, let's go ahead and look at this guy. This has a base of 1 and a height of 2. So this area would be 1/2 times 1 times 2. So it looks like I'm going to have an area of +1. This area, let's see, I have a base of 2, and I have a height of -4. Now, you don't have to put the negative in here, but you do need to accommodate for it at some point. So I have to account for this being negative at some point. So if you don't write the negative in now, make sure you tag it at the end. So here, this will have an area of 4, but like I said, this is -4. Okay, so my net area would be -4 plus 1, or a net area of -3. Boom. So this integral equals -3. All right. I titled this video Triangles and Circles, so let's talk about a circle problem. What if I had the integral from 0 to 2 of the square root of 4 minus x squared dx? All right. What I would suggest doing is opening up Desmos, graphing y equals the square root of 4 minus x squared. And what you're going to get is that this is actually, in Desmos, the top half of a circle of radius 2. Okay, so that's what you're going to get from Desmos when you graph that. Okay, now I only care about the area from 0 to 2. So does it make sense that, again, I wouldn't want to use rectangles, and in fact, I wouldn't want to use triangles? This is just the quarter of the area of a circle, and that circle has a radius of 2. Okay, so the area of a circle is pi r squared, and I just want a quarter of it. So either multiply by 1/4 or divide by 4. And I believe we're going to get that our area for this example is pi. Beautiful. So in this section, they're trying to really get us to think about what shape best fits it from geometry. So here, obviously, it is a circle, or at least a quarter of a circle. And in this example, it's triangles. All right, so be on the lookout for this in our homework. Good luck.